Image number 1, Unveiling the Crab Nebula. Within the constellation of Taurus lies the Crab Nebula, a captivating canvas of cosmic activity. This nebula, also known as M1, has been captured through the powerful lenses of the Webb Space Telescope's NIRCam and MIRI instruments. The image you see may seem inverted because it's a sky map, not an Earth map, so we're looking up into the sky rather than down onto the ground. The scale of this image is immense, defined by light years, the distance that light travels in 1 year, which is about 5.88 trillion miles. The light we see in this image began its journey 6,500 years ago, traversing vast expanses of time and space to reach us. The image covers a stretch of 10 light-years across the nebula. At the core of the Crab Nebula is a pulsar, the remnants of a supernova explosion. This pulsar spins rapidly, flashing like a lighthouse beacon as it emits intense beams of radiation. The Crab Nebula is not just a remnant of a dying star but also a birthplace for new elements that form planets and life. In this 5.5 arc-minute wide snapshot, we witness a part of the universe's continuous cycle of death and rebirth. The destruction of the supernova has given rise to a nebula teeming with new elements, highlighting how intertwined creation and destruction are in the cosmos. The Crab Nebula is a testament to the dynamic processes that govern the universe. Its vibrant colors and intricate structures tell a story of transformation, where the explosive end of a star has sown the seeds for new beginnings. Isn't it marvelous how destruction and creation are woven together in the fabric of the cosmos? Image number 2, The Majesty of MAX 0416. Gaze at the image of MAX 0416, a galaxy cluster so massive that it bends light around it, a phenomenon known as gravitational lensing. This cluster has been captured by the Hubble Space Telescope in visible light and by the Webb Telescope's NIRCam in infrared, offering a dual perspective on this celestial marvel. The compass arrows in the image might seem backward, but they simply reflect the sky's orientation from our ground-based point of view. The scale is measured in arc-minutes, a sliver of the sky's vast canvas, with the entire image stretching just over 2 arc-minutes wide. Though this angle is tiny, it represents an immense portion of the cosmos. Formerly known as MAX J0416.1-2403, this cluster lies in the constellation Eridanus. It's a gravitational lens, warping space to magnify and distort the light of galaxies behind it. This effect is like looking through a cosmic magnifying glass, revealing galaxies that would otherwise remain hidden. Clusters like MAX 0416 are not just fascinating subjects for images, they are also critical to our understanding of how mass is distributed across the universe. Through MAX 0416, we peer deeper into the universe's mysteries, unveiling the secrets of dark matter and the large-scale structure of the cosmos. Image number 3, MAX 0416 and the marvelous Mothra. Venture into the cosmic depths and feast your eyes on MAX 0416, a galaxy cluster with a special twist. This isn't just any cluster, it's a colossal cosmic magnifying glass, bending light across the eons to unveil a spectacular secret, a distant galaxy that flickered into existence a staggering 3 billion years after the Big Bang. Among the stars in this galactic ensemble, one stands out, a star fondly named Mothra by the scientists charmed by its brilliance. Mothra isn't an ordinary star, it shines with light magnified over 4,000 times, acting as a brilliant beacon that has traversed time and space to greet us. The power behind Mothra's extraordinary glow is the combined might of MAX 0416 and a mysterious microlens, a dense celestial body with the mass of a swarm of stars known as a globular cluster. This discovery, nestled in the constellation Eridanus, is a testament to the wonders of the universe and a thrilling clue in our cosmic detective story, as we unravel the nature of the universe's hidden mass. Each glimmer in the vast dark sky is a story, and Mothra's is one of ancient light amplified across the ages to reach us against all odds. What other secrets might lie out there, waiting to be magnified into view? The universe is full of such dramatic tales, and MAX 0416 is just one chapter in the grand cosmic narrative. Image number 4, Webb's groundbreaking discovery, thorium from a star merger. In a celestial drama of epic proportions, the Webb telescope has struck scientific gold, or rather, thorium, detecting this rare element in the cosmos. 2 neutron stars, remnants of stellar explosions, danced their gravitational tango in a distant galaxy before ultimately merging in a cataclysmic event. The prelude to this discovery began with 2 stars bound by gravity's inexorable pull within a spiral galaxy far beyond our own. Each star met its end in a supernova, leaving behind neutron stars, incredibly dense celestial objects. Propelled by their explosive births, these stars embarked on an intergalactic odyssey, finally colliding after several 100 million years. This violent merger set the stage for a spectacular cosmic light show, a gamma-ray burst, GRB 23307A. An explosion so powerful, it shines with the light of 1,000 novas. GRB 23307A, first spotted by the Fermi Gamma-Ray Space Telescope, stands out as the second most luminous gamma-ray burst we've ever seen. Webb's infrared capabilities allowed scientists to pinpoint the origin of these neutron stars and witness the aftermath of their merger. It's here that Webb spotted signs of thorium, an element scarcer than platinum on Earth, within the kilonova glow. This marks the first time such a heavy element has been directly observed in the aftermath of a neutron star collision. The significance of this discovery is immense. Kilonovae are now confirmed as cosmic forges where the universe's heavier elements are crafted. Webb's detection of thorium is just the beginning, with astronomers on the brink of uncovering more secrets of the cosmos, revealing the origins of elements that construct the world around us. Image number 5, the distant beacon unveiling a primordial black hole. Astronomers have peered across the cosmic expanse to witness a black hole from the universe's dawn, using the keen eyes of the Chandra and Webb space telescopes. This black hole, detected through its X-ray whispers, holds the record as the most distant one we've ever seen, shining from a galaxy known as UHC-1. Such X-ray emissions are the hallmarks of a supermassive black hole feasting on surrounding material, growing larger with every bite. The black hole story unfolds against the backdrop of the galaxy cluster Abell 2744, imaged here in infrared by the James Webb Space Telescope. This cluster, nicknamed the Pandora Cluster, is a cosmic crossroads, a gathering of galaxies whose light has traveled for billions of years to reach us. As we dive into Webb's infrared portrait, we find an ocean of darkness sprinkled with distant suns and galaxies. These dots of white, orange, and purple light are not just points but entire galaxies, each with its own stories, spiraling and stretching across the void. Among this cluster of galaxies lies an inconspicuous orange star, seemingly modest, yet it's a beacon from the past, signaling from 13.2 billion light-years away. That speck houses a burgeoning supermassive black hole in the galaxy UHC-1, offering a rare glimpse into the early life of such cosmic giants. This image is not just a photo, it's a window into the early universe, providing clues to how the first supermassive black holes emerged. It's a profound reminder of the vastness of the universe and the enduring mystery of its origins. Image number 6, a cosmic confection, galaxy M83 through Webb's eyes. Feast your eyes on the splendor of M83, a barred spiral galaxy revealed by Webb Telescope's MIRI instrument. This isn't just any celestial snapshot, it's a galaxy in full bloom, displaying its swirling arms in a spectacle of cosmic creation. The galaxy's core glows with a congregation of stars, shimmering as bright blue specks against the backdrop of space. These stars are densely packed at the center, illuminating the galaxy's heart with intense light. Surrounding this luminous core, the galaxy's spiral arms unfurl like cosmic ribbons. These vast lanes of gas, dust, and stars stretch outwards, painting a picture of dynamic motion. The arms glow a fiery orange, tracing the paths where the galaxy's raw materials converge to give birth to new stars. The rest of M83 is a canvas of darker reds, with pockets of interstellar material providing the ingredients for stellar creation. Peering through the gaps in the dust, we glimpse countless stars dotting the expanse, a testament to the galaxy's vibrant history and ongoing evolution. This image is more than a treat for the eyes, it's a window into the life cycle of galaxies, showcasing the ongoing process of star formation and the intricate structures that make up the universe's grand design. Image number 7, Jupiter in ultraviolet. This image from the NASA/ESA Webb Space Telescope shows the planet Jupiter in a color composite of ultraviolet wavelengths. The Great Red Spot, a giant storm larger than Earth, appears red to the human eye, but in this ultraviolet image, it looks darker. This is because high-altitude haze particles absorb light at these wavelengths. The reddish wavy polar hazes absorb slightly less of this light, possibly due to differences in particle size, composition, or altitude. The data used to create this ultraviolet image is part of a Webb proposal examining Jupiter's elusive superstorm system. Webb continues the legacy of observing the outer planets, building on the historical groundwork laid by telescopes like Hubble. From tracking the aftermath of the comet Shoemaker-Levy 9 impacts to studying Jupiter's tempestuous weather systems, Webb's cutting-edge capabilities and unique position in space furnish astronomers with essential data to trace the evolution of this dynamic planet. Webb's ability to observe in ultraviolet wavelengths allows astronomers to study the short, high-energy wavelengths of light that are invisible to the naked eye. Ultraviolet light uncovers fascinating cosmic phenomena such as the glow from the hottest and youngest stars nestled in nearby galaxies, the composition, densities, and temperatures of the interstellar medium, and the evolution of galaxies across the universe. Image number 8, TW Hydra Disk Shadows. Comparison images from the Webb Space Telescope, captured at different times, have revealed two mysterious shadows moving in a counterclockwise direction across the gas and dust disk encircling the young star TW Hydra. The disk's orientation is face-on from Earth's perspective, offering astronomers an unparalleled overhead view of the surrounding star system. The first image from 2016 shows a lone shadow at the 11 o'clock position, cast by an inner disk slightly tilted relative to the outer disk, which obstructs some of the starlight. The second image from 2021 highlights an additional shadow at the 7 o'clock position, indicating the presence of another nested disk. These shadows shift around the star at varying speeds, reminiscent of clock hands in motion, providing indirect evidence of unseen planets whose gravitational forces have sculpted the dust into their own inclined orbits. These observations, made in visible light with the Space Telescope Imaging Spectrograph, have been artificially colored to accentuate the intricate details of this cosmic phenomenon. The interplay of light and shadow in these images offers a glimpse into the dynamic processes shaping the formation of planetary systems. Image number 9, Winds in Jupiter's Great Red Spot. In a fascinating study of Jupiter's most famous feature, the Great Red Spot, analysis of images taken over an extended period has unveiled intriguing changes in its winds. On the vast canvas of Jupiter's atmosphere, this storm is a titan, and the winds that rage along its outer edge have been found to accelerate, with speeds now topping an astonishing 640 km per hour. Encircled by an outer green boundary, these winds have intensified, showing an uptick in their ferocity. Curiously, this escalation in velocity isn't uniform across the storm. Moving inward, where another green circle marks a boundary closer to the center, the winds adopt a more leisurely pace. They meander more slowly, providing a stark contrast to the outer edge's bluster. Despite their differences in speed, both the inner and outer winds share a counterclockwise dance, twirling in harmony around the Great Red Spot's center. This storm, a feature so large it could swallow Earth whole, continues to captivate and puzzle astronomers. The increasing speeds at its outer edge could hold clues to understanding the dynamics of Jupiter's atmosphere and the longevity of this centuries-old storm. Image number 10, in the heart of the furnace NGC 1385. Cast your gaze into the depths of space and you'll discover NGC 1385, a spiral galaxy ablaze with starlight, nestled in the constellation Fornax. The name Fornax, which translates to furnace in Latin, aptly captures the essence of this stellar forge, located 30 million light-years from Earth. Unlike other constellations named after mythological figures or animals, Fornax and its celestial neighbors bear names celebrating the tools of enlightenment and discovery. This galaxy, a jewel in the furnace's heart, is a grand spectacle. Its swirling arms, rich with the glow of countless stars, weave around a bright core. Each star is a spark from the celestial anvil, illuminating the galaxy with its radiant light. The constellation, created by a French astronomer with a fondness for the instruments of science, stands as a tribute to the eternal flame of human curiosity and our quest to chart the cosmos. The story of NGC 1385 is one of continuous creation and transformation, where the raw materials of the universe come together to form new stars and structures, perpetuating the cycle of cosmic evolution. And with that, we glide back from the cosmic sea to the shores of our blue planet. If you've enjoyed this stellar journey through the eyes of the James Webb Space Telescope, leave us a like. To navigate the stars again, don't forget to subscribe and hit the notification bell to join our next voyage across the universe. Until then, keep your gaze skyward and keep wondering. Ready for more cosmic wonders? Click on the next video and continue exploring.